Welcome you all for the day 7 training. And today's training, you'll be understanding some of the important factors about how to give formulas and relations. First, you need to understand what is meant by formula, and then understand what is the importance of relation. So when we talk about any of the designs, specifically parametric modeling, it's very important that there should be associativity between the features what you're going to create it. And I'm going to create only for the first time a component and followed with giving parameters and relations between different features so that my design is made as one parametric modeling capabilities. That means I'm going to create only one part model, and using that part model I'm going to create many n number of configurations. So that is one thing which you need to understand in terms of parameters and relationship. Let's quickly get into the application and understand what exactly it is. When we talk about parameters, the parameters means I'm going to give relation between two features. There are two types of relations. One is called the relations which we can create using the features, which is intrinsic parameter, and one more is called eccentric parameter. That means there is no relationship with the features. To start with, when you create a plane, when you create a point, when you create a sketch, when you create a line, when you create any of the feature, in CATIA, default a naming conventions or a log file is created for that one. Means when you start creating a sketch on a XY plane, a rectangle, it has length and width, right? So it takes that one as a log file. That is intrinsic parameter. Whichever you do in sketch, whichever you do in pad is called intrinsic parameter of the features. Let's quickly get into that one. First, I'm getting into mechanical part design. Understand that this is a feature which we are going to learn today. That means we are going to learn something called formula. This formula is a very important feature where you can able to create the feature based on the design aspects in terms of relating each and every component. First, you understand how these formulas will appear on the screen. The formulas will be appearing on the screen like a relation, which is a part of your part body and a part. That means the moment I create a feature in this particular sketch on this particular plane, XY plane or YZ plane, what we have selected, give OK. That means this also is an activity. Selection of a plane is also an activity. The moment you just go and draw a rectangle using this one, a centered rectangle, this is also an activity. That means I am just creating this feature on the sketch. That's what we understood, right? All this constraint. See, this is my length. So the moment I just go and give that this is my length and this is also my length. See that you can see at the bottom 7 is coming and length 8 will also come. So that means this sketch, whatever I divide, is something like this 100 and this one has 250. And this sketch is not fully constrained. That means it is flying in space. So I'll select this point and I'll select this particular center point and give constraint. So that means it gets constrained, right? You know that one. So these are all the parameters: parallel, equidistance, length, coincident, which is an intrinsic parameter of the feature what we have created. Say for example, when I create a pad for a thickness, say for example, I'm going to create a pad for this thickness, say for example, creating 20 mm, a reverse direction, right? So that means this is also a feature. That means when you start creating any feature, you will have a parameter which I can correlate and start giving the dimensions. In this case, for instance, my requirement is that this is my width, right? This is my width, this one is my width, and this is my length, right? I would like to make my length twice of my width. So I don't want to give each and every time the sketch dimensions, right? I don't want to give this dimension each and every time, 250 or something like that. So that means the moment I change this 100 mm, it takes it up. The moment I just do the thickness, I just give the relationship such that automatically it takes it up. So that's my objective. The first thing what you need to understand is we are going to give relationship. So for instance, this is my relationship. I'm just going to click on my formula. So if you see that, what are the activity we have created? I was just telling you, right? Each and every activity, geometrical set, I created an activity. All this one, everything. See, this 20 mm is my thickness. The moment you just click on this one, you can see this 100 mm. See this 100 mm is length 7, right? That's what you can see that, which I showed you. Length 7. And length 8 is nothing but your 250 mm, right? So that means each and this 20 mm is also a feature which I just created. That means these features which are driven basically by the design aspects of how I'm doing each and every activity is called intrinsic parameter. Are you guys with me? Please let me know. Perfect. So in this case, my objective is I would like to make this one twice of or thrice of something like that. So the first objective for me is that, see this, just give, okay, you can see this. Where you can able to see all this one, go to f of x and click on this feature, you can see all this one. I'll repeat once again. Go to f of x. You will not know what to know. Just click on the feature. Then you can see what are the features available. Click on this one. Every feature is visible for you, right? So the first objective for me is that I would like to create a parameters or relationship between each and every feature. So I'm just moving all these features to the other side using my feature. So the first objective is that when I start giving formulas, I would like to see those formulas on my specification tree. Remember, when I give formula, I would like to see all my formulas on my specification tree. How to view that? The first important things. Let us go to tools, very important. Tools, option. I'm going to repeat it. What is the reason behind it? Tools, option. Okay. In that case, you will have tools, option, infrastructure, and part infrastructure, right? Where you will have the second tab, parameters and relationship. I'm just going to switch off this at the moment just to make you understand. It is on, I'm going to make it off. So what is the meaning of this one? See this, tools and options, right? Infrastructure, part infrastructure. You have something called display. What is the meaning? You just read the statement. Display in my specification tree. What I would like to display in my specification tree? I would like to display my parameters or relations in the specification tree. Our objective is that one. So at the moment it is off, right? Just give okay, fine. Now I'm going to create formula. See this. I'm just going to click on this one, f of x, and I'm going to make the relationship. So I want to make a relationship that this 250 is 2.5 times of this 100, right? So go there, add formula. I'm going to make that this length 8, this 250, you can see the moment I just created f of x, right? The moment I just created, you can see the f of x just appears on this one. So I'm going to relate that 250 is equivalent to 100 into, just see, star 2.5 times, just to make you understand. So that means what I did, I just gave a relationship that my length 8 is equivalent to length 7 2.5 times, sorry. The moment I just give 2.5 times, you can see that it becomes 250, and you can see on the formula that geometrical set the sketch is active and it is 250 mm. And apply it and give OK, it gets changed. And you can see that the formula is not appearing in the specification tree. So that means what we should do? We should go and activate that one. So that means go to Tools, Option, get into my infrastructure, part infrastructure, go to my display, right, and make this relationship on. And the moment you give this relationship on and just observe in the specification tree, you just observe in specification tree, right, just give it OK, you can see the formulas will be appearing on the specification tree. So that's what we are given, right? We are given the length 8 is equivalent to length 7 into 2.5 times, right? So that's a formula. So similarly, I'm going to create f of x, right? And I'm going to change this thickness. See this 20 mm, right? I'd like to make this 20 mm. So the moment you go and select this 20 mm, see this is my 20 mm, first limit. I'm going to add this formula. See this, I'm going to just add this 20 mm I selected. I just selected this for 20 mm. And I'm going to make an add formula. Add with what? You can correlate with anything else. Just I'm going to add formula. I can add with the formula with the relation to this or with the relation to this, provided there should not be any ambiguity in the design aspects. So in this case, I'm going to select this 100 and I'll put divided by, say for example, 5 times or 6 times. Make it 6 times to make you understand. 100 divided by 6 or 4 times, let it be 24. That means the moment I just give it, you can see that it has changed into 25. 100 divided by 4 is 25. And give OK. Now your pad is changed. So that means when you start designing the feature, you need to understand that parameters and relationship plays a very, very critical point. Let's go and check it on the sketch. So now I just made this 100, right? And if I just make this one to 50 mm, the moment I just gave to 50 mm, this becomes 125 because 2.5 times, and 50 divided by 4 could be this my pad. So if you just go to my pad, it will be something like 12.5 mm. So that means I just gave a relationship. But one of the toughest challenge for a common man, any designs, it should be very clearly defined, right? It should be very clearly defined. Until unless we define it very clearly, you will have a confusion. You'll have a confusion. Always, what is a common man's confusion? Why this big length? You know this is nothing but width, length and thickness, simple as that. But here if you see, the geometrical set sketch dot 1 length dot 8 and length is equal to geometrical set sketch length 1 length 2, all this is a big challenge. So it leads to confusion. It leads to a confusion. Can we make it very simple? Like this is my length, this is my width, simple as that, and this is my thickness. So what I'm going to make it? Just I'm going to click on my sketch. See this? I'm just going to click on my sketch, and I would like to rename this one, right? This is my width, right? I'm going to make this one, right click, edit this one. See, I'm going to just double click on this feature. Which feature? This particular feature, that is this geometry, 50 mm. Right click inside this one using your right mouse button. very important. You can see edit and just edit this one. In this term, what I'm doing, this is my thing, right? Geometrical set. You can just see this. This is my point, right? Geometrical set, length 1, length 2. That's the same thing, right? Just go there and see this one. You can just see this. Length 1, geometrical set, length 7. So in this case, what I'll do is that I would like to change this. I'm going to change this as width and just give OK. The moment I just give width, you just see here in the specification tree, right? In the specification tree, you can see that it has got changed as width. Here as well, here as well. So this becomes easy for a common man to understand, right? Similarly, I would like to change the length as well. So I would like to make this one as length. So double click on this one and right click on this one. Go and select this one, edit. And here, instead of this one, you just make it length. Right? Just give it length. You got it length. And give OK. Now your length is width into 2.5 times. That's the meaning. And similarly, just see this one. The moment I just double click on this one, this is my formula, right? This is my formula, which is getting into knowledge ware. No need to worry at the moment. Just go back to my pad. And this is my pad. And just click on this pad. And I would like to change this one as well. So this is my thickness. So I will right click on this pad thickness, which is already given formula. That's the reason you can't edit this one, because we are given the formula. The moment you give the formula, you can't edit any of the feature, because if you change 50, then it gets changed. So now I'm going to just check here, right click and edit this one, and I'm going to make this one as thickness. And just give OK, you get this thickness. So that means now you are very clear. My length, width and thickness is the formula. You will ask me, can I give any formulas any point of time? As simple as that. Can I give any formulas any point of time? Yes, possible. Provided there should not be any ambiguity. Just go there to this formula, right? The same formula. And just see this one. This is my formula, right? Just double click on this one. You can just see my thickness is 4 times of width. Why we should give this one? Can I select and just select this one? I can make length also, right? Thickness is nothing but length divided by 5 times, possible. Give it OK, provided there should not be any ambiguity. So now if you see this pad is driven by, so this is driven by this particular value. Just give OK, fine. And now if you change any feature, say I'm going to geometrical set and changing the sketch from 100 to 150 for example, it changes, right? And this also gets changed and this also gets changed. So that means your parameters and relationship keep changing based on the profile. So if you just go and check your formulas and click on this one, you can just see all this one. So this is my 73, 75 and this is my 373. All these inputs will be given. So you would like to do these changes, go and just edit this one. And I would like to change this divided by 6 times for example. So you get this value. So at any point of time you can give any number of values. So this is called intrinsic parameter. So now what we'll do in this case, I would like to make some inputs, some specifications. So this I did after creating it, right? Which is a complex thing. And if you see your specification tree, you can see this length and width, everything. And if I'm just going to repeat the tools and options, if you're not making your parameter display this one off, you will not see your specification tree, your formulas. It doesn't mean that the formulas are gone. Yes, formulas are there. Still the formulas are there. But you can't see in the specification tree. That's the point. You can't see that one in the specification tree. Formulas are there. See that I just created 10 mm, any formulas you can just do, it works. That is my feature, and this is my pad for a dimension of 4.6 mm, 1.6 mm, anything is possible. Formulas are there, but you can't be able to see that one. Just go do it, and this is what we in the industry we call as configuration management. What is that called? Configuration management. Why we need configuration? I can't create any n number of components same time, right? I just do only one, give relation, and I can have like this 10, 12, 15, 16, 17, 18, and from different dimensions. I can have any number of dimensions, right? In this case, only 10 is there. I would like to have 12, I would like to have 14, I would like to have 16 width. So I will get different configurations. How you design your bolts and nuts? I will design only one bolt. Based on one bolt, I can create a number of different configurations. So for different materials as well. So that is the process which you need to understand while creating the formula. Let's quickly get into one of the exercises. I'm just going to close this one, and I will give a simple example. I'm going to design a simple bolt for you to make it very clear. Go there, File, New, and Path. Just give it. The moment you just go and create a part, go and create a sketch and give this sketch. I'm just going to create a sketch. Now I'm going to teach you different, right? Very important. Just see, I'm going to make this one a bolt of dimension, some dimension. Just take it this one, and this is my bolt, right? Just constrain this one. And always I told you, right, the earlier session also, always use axis system. Why we should use axis system? You know that, how to dimension a bolt. So now, see this, I'm going to select this one and this one, right click, radius, you get this one, right? So this is my radius. I'm going to change it to radius. And similarly, I'm going to take this one and take this one. This is my dimension. So I'm going to constrain everything. Take this one and this one, right click. So okay, let it be this one. And then I'm going to make this one and this axis, right click, I'll have a radius. Right, this sketch is fully constrained now, right? Sketch is fully constrained. So what I will do, so this is my radius, right? And I'm going to see this one, radius, I'm going to give this one as 10. And right click. Now itself I will start editing it, rather than going and later editing it. I'm just right clicking it and just change this one as my head diameter. My head diameter or head radius. Head radius. Just give it okay, you get this one. And just give okay, you get this head radius. And similarly, just double click on this one, and I'm going to right click and here, and I'm going to just name this as head length. That I'm going to just name this as head length. And I'm going to name this head length as 8 mm and just give it okay, fine. I just made it round value. And similarly, this is my shank length. Just double click on it, edit this one, and I'm going to name this as shank length. Shank length of dimension 40 mm. Just to make it a round figure. And give OK, you get this one. And then I'm going to take this one and right click on this one and making this one as well as shank radius. And I'm going to give this one value as, say for example, 8. Apply, just give it okay. Now what we did, we just gave all this one. So this is, I'm going to give this one, I don't know whether it has got changed. Let's go and check. It's not get changed. Let's go and give this one as head length. So this is my value, right? So just go there and check this one to 10 or 8. Or this, I'll make it to 12, right? So now if you see, I'm going to revolve this one with reference to axis. This one with reference to axis, you know this one message will pop up because this is in geometrical set. You get your bolt. Now, if you go and click on my formula, so that when the moment I just click it, you can see all your parameters, whichever I got, it got renamed easily. You see this? Got renamed, it got renamed, it got renamed, right? And this formula is not only available in part design, it is available even in Sketcher. So you go to Sketcher, you get this formula, right? That's what. Even in Sketcher, you have this formula. See this? This is my formula available in Sketcher as well. And this same formula is available in part design as well, right? This one. So in this case, I would like to go there in Sketcher and I would like to teach you how to give the formulas in Sketcher, so that it's very clear that the formula is available in all the features. Part design, assembly design, all these. Now with the moment you just click on this one, it is very difficult to search, right? Which is 12, which is 8, which is 40. But what we did, we renamed it, right? So filtering becomes easy. Filtering becomes easy. Now what I'm going to do, I'm going to select here that this is my feature called parameters, renamed parameters. I renamed, right? All features are there, all parameters are there. I'm going to rename the parameters. So the moment I just go and select my renamed parameters, you can see all these factors. It's very easy for to understand. Now what you know, my head radius is this one, 12 mm. I can add formula. Renamed parameters. See that my head radius, very important, my head radius is equivalent to what? That's the concept. My head radius is equivalent to my shank radius or something. You can give relationship, but there should not be any ambiguity. That's the only concern for me. You can give relationship formula with any parameters. So now what I'll do, I don't know which parameters, just go and select renamed parameters. So now I have my renamed parameters. That means I can make my head radius is equal to head radius. I cannot do it. That's not possible. So I can just work with this one. So shank radius. So what I'll do, my head radius is equivalent to my shank radius. Just double click on it. It comes. No need to type it. Just double click on it. So plus, very important, very important. I'm going to make it 2 mm. 2. If I give 2, what happens? It takes into SI units and makes it 2000. See this. You can see the change. It takes units 2008. That's not a factor. So that means what? You see that? When I'm not giving the unit, you can see that it takes like this. It's not correct. So 2. What 2? 2 mm we should give here. That's my parameter. Okay? That means just edit this one. And just give here 2 mm. So I just gave the formula. See this? This is my formula. Put it normal view just to make you understand. I just made it. Then what I would like to do, I would like to create my head length now. I'm going to select my head length. Add formula is equivalent to, you can give this with reference to head radius also, right? Head radius minus 2 mm. See this? 2 mm or whatever. 2 mm. So I just give 2 mm. So that it becomes 8. That becomes 8. Apply it, you get this formula. Then my shank length. I'm just going to give my shank length. What is my shank length? My shank length is 40 mm, right? This is my 40 mm. This is 40 mm. I'm going to add formula is equivalent to 8 multiplied by, for example, star multiplied by, I would like to give some 8 times 64, 8, 8, 64. Just give OK. You can say that this bolt dimension becomes 64. You can give anything. And apply this, and give OK. And now your design is that you have created the model based on this input. So you want to change this bolt radius, what you do? Just go there and check this parameter. So I'll just check this one and right click my edit formula. This is my formula, right? I can edit this formula as well. There are different ways. I'm going to give plus 4 mm, for example. Give OK, you get this one, and exit this one, you get this one. See this? It gets updated. So that means here the parameters are not coming in screen. So that means what we should do? Go to tools, option, parameters are not appearing. Intentionally I made it. Go there, go to my relationship, that is infrastructure, part infrastructure, make it show. The moment you show that one, your parameters is visible on the specification tree. That means it's very clearly evident that the shank radius is the controlling factor for this one. Are you guys there with me? Please let me know. Thank you very much. So in this case, what we learned how to give a formulas and relationship, parameters, and how to edit those parameters. And it is very easy, right? When you click on this one, I can able to see your renamed parameters, and all these renamed parameters is a part of your design, right? Apply it, give it OK. So now, what is the biggest challenge? First, what we had is a challenge, renaming. I did that one. You understood how to rename it. And always remember, when you keep the values, of this one in terms of diameter, right, you cannot rename it. First important note, errors. What are the errors will come? You can't rename it when it is in diameter. I'll show you an example, okay? This is my component. So that's the reason I just converted into radius and renamed it. When it is in, see, for example, it is in diameter. This is inner diameter, right? Sorry, this is my head radius. Right click. You want to edit this one, see. Right click. You can do it. It's not possible. You can't do any edit. If it is in radius, you can able to do this one. Right click. That means when you want to rename any of the radius alone or cylindrical component, if you are in diameter, you can't rename it. So better always change it to radius. This is a very important. So many people misses this one. Right click and put it in radius, then you can see this formulas available. If you are putting in diameter, you can't able to edit the naming conventions. Now if you put this in radius and right click on this one, edit. So I'm just putting a full stop or underscore R. Apply it, you can see underscore R, right? You can just see. So when it is in diameter, you can't change it. So that is a fundamental thing. That's the reason I drew an axis and then I did it. Now Bernard, what you did, everything good, fine. So this is a simple bolt, great. But if it is a complex design, how I am going to control those features? Each and every time I have to go and control. Now controlling factor for me is which one? This particular shank. And we all know this is the factor. The third person who is not attending our training, he will not understand which is the factor which has to be changed, right? So that means we all know that this is my controlling factor at the moment. So that means if I change this 10, the other bolt, every dimension also gets changed. We all know that one, because we all see that one. But always remember, the design has to be very clear and easily understandable for each and every person. Today you are working, today you leave the company and you can go and join another company, but the process has to be strict, process driven. That means in this case, your geometry has to be fixed, your dimension has to be fixed. How you can change it? So here it is very difficult. This is a bolt. If you have a complex sketch, like yesterday's model, we don't know where to change, which is the driving factor, we don't know. So that means now you take a call how you can do this change. So at each and every time, I don't want my thing to be changed here. I don't want this to go to sketch and do it. I would like to have one more parameter in the specification tree. I will create one more container, right? I'll be creating one more here with the yellow. I'm just making it. I'm going to create one more here, something called parameters meter. Under that parameter, I'll put this shank radius, nothing but this shank radius, so that the moment I go and change there, automatically the model gets changed. This is what we call an extrinsic parameter. So what is the unit which is getting changed? Now, first we need to understand what is the unit getting changed. When I do this change, the unit is getting changed is nothing but your radius. The unit of radius is what? Mm. That means it's a length type. It is a length type. So what I would like to do, I would like to change each and every time I'm going and clicking on sketch, and which is a difficult chance. I don't want that to happen. I would like to create a parameter. That means go to tools, right? You can see that there is one more terminology called parameters. This parameters. I'm going to make this parameter visible. So that make this parameter visible. Give OK. You can see this parameter coming on the split. Now, what we'll do? Now click f of x. Click f of x. Until now, all this parameter, head radius, head length, shank, it's a part of your design, right? We did a sketch, the sketch design. But now I'm going to create my new feature. It's called extrinsic parameter. What is the unit? I told you that unit is length. So I'm going to change here in the parameter as length, right? This is my length. And if you see this one, very important. Your head radius is a part of your design. Your head length is a part of your design. Your shank length is a part of your design, right? Every formula is all active. Your head radius is a part of your design, correct? Everything is a part of it. Now what I'm going to create, I'm going to create a new parameter. See this, I'm going to create a new parameter with a single value, right, of length type, because the unit of here radius is mm. So I'm going to create length of mm type and start using it. So in this case, I'm going to create a new parameter called new, for understanding, shank radius, right? And I'm going to give this dimension as, say for example, 12 mm. The moment you give this one, you see this in the specification tree, you get new shank radius 12 mm, which is not of any part design or nothing, right? Just give it, apply and give OK. What I did, I just created my new parameter of type length, whatever it is, and renamed it as new shank radius. I'll teach you once again, don't worry. And give OK. Now if I go and change this value, see this, if I go and change this one to 15, is there any effect? No effect, because it's not a part of your design. It's not a part of your design. If I go and change this one to 8, it's not a part of your design, nothing, right? Are you guys following me? Please let me know. Thank you, Rudra. Thank you, Guru. It's not part of your design. So what we should do? I would like to have a relationship now. That means this is a parameter which I got by saying tools and options, right? By making this parameters on the infrastructure part, infrastructure, second tab, display, you get this one. The moment you make it off, you can't see this one. See this, you can't see that. You can't see, even though it is created, very important. Even though it is created, you can't able to see that. So the first option, tools, option, go there and select here with parameters and just give OK. You get this parameter, right? Parameter. And some time, if at all you're doing for the first time, you can't able to see these values as well. This is my value. What is the value we are given? When I click on my parameters, I just gave this value. So now if you click on my f of x, and select this one, and all your renamed parameters you would like to see this, all your renamed parameters including this will be visible, right? All will be there. So now what we'll do is this, see this, I'll go to my sketch so that you will understand, and click on this f of x, and you select all my renamed parameters. See this, radius is there, head length is there, shank length is there, this is also, shank radius is also there, new shank radius is also there. And what is the value of new shank radius here? I just given 8. That's what the 8 is appearing over here, right? You can change it to 10, 12. Apply it, you can just change it to 12. Okay, you can see this. Sometimes you can't see that. That means if for the first time you are doing these formulas, you can't able to see this feature on your screen, specification tree. That means go to tools, option, see this, option, tools, option. There is something called parameters, tools, option, parameters. Just see this, tools, option, parameters. At that particular point, width value, you just see this width value. This width value is not there, you will have a problem. So if you make it off, see this, if it is making off, this is what happens. Most of the people ask me doubts, that's the reason I'm just covering this important point. And the same thing is available in my tips and tricks. You can just watch it in YouTube, the tips and tricks. You forget even. So this is with value. Just make this one with value off at the moment. The moment you make it off, you can't see this value. But it's there, don't worry, it's there. In the back end it's there, but it's not visible for you in specific. See that it's there, 12 mm is there. I can say 8 mm is there. But you can't see this value. That means go to tools and options. If these values in the parameters are not visible, make a note. Go to tools, option, general, parameters with value. Just give it OK. That you can see that. And now, once again, this has no effect, right? This has no effect. See, this has no effect. I'm going to make it as 15. Give it OK, fine. Now, what is my objective? My objective is now to give the relationship. See this? My objective is to give the relationship. For the which, what I'm going to do, very important, observe here, f of x. F of x. In this case, you have shank radius and you have new shank radius. Now, what I would like to make, see this, I'm going to select my shank radius, which is nothing but 10 mm, which I would like to make it equivalent to 15 mm. That's my objective. Not 15 mm is equivalent to 10 mm. So the first thing is that my shank radius, which is 10 mm, is equivalent to 15 mm. So what you should not do the other way. Shank radius, which is a part of your design, right? This is my new shank radius, which is not a part of your design. It's an extrinsic parameter. So what we are going to do in this case is that add this one. Which one? This shank radius. This is my shank radius, which is equivalent to, see this, which my new shank radius is equivalent to my new shank radius. I'm sure I'm increasing your bar, your learning practice, but this is a must. You need to know this one. Okay. So what I made, my shank radius, which was 12 mm, I'm going to make that one is equivalent to 15 mm. Now you just give it apply, and that's now you see that my shank radius, which is earlier 12 mm, 10 mm, sorry, or 12 mm, I made it into 15 mm, and apply it and give it test change now. Now for me, is it easy, right? I don't want to go there. That formula also gets captured in this here. See, my shank radius is equivalent to new shank radius. That also get captured. Now what I'll do, just see this. I don't want to change. I don't want to go to my sketch and change it. Now I just go there and just keep changing here. See this 17 mm. Just go there and just change over here 18 mm. So now any new person comes, oh, this is my parameters, new shank radius. So I just go there and change it to 25 mm. So the design is up. I'll go there and change this one to 50 mm or 80 mm, whatever the bolt size you would like to have it. So something like that. Provided your ambiguity in the dimension should not come, right? So let us go and stick on to 12 mm first. And see that you get this, your bolt of this dimension. So you feel that, okay, I should do some changes, 1.5 times or something like that, my shank radius, head radius, just go there. Is equivalent to, just double click on it, my shank radius into 1.2 times, something like that. My head radius is equal to 1.2 times. Apply it. There is could be a challenge, so I should do multiply it. Just go there, sorry, go there, and shank radius multiply star, I missed it. Let's give it okay. And this time, this also you can change it. My head length is equivalent to, what is my head length? Just see this. You can just do anything this. So now whatever dimension you change over here, it will be 1.52 times. See this? Go there and take it up. You can see this. You can change it. This also you can change it, right? You can see it is deactive. You can just make it up. So that means whenever you start giving the formulas and relationship, it's very important that you should not have any ambiguity in the designs. Are you guys with me? Please let me know. Perfect. Thank you very much. Great. So in this case, what we did, we just created the formulas and relations, and this is my one value. Aryan will tell, Bernard, you are creating one value which is 12 mm. I can give 12.2 mm also, which bolt cannot be manufactured, right? So what I would like to do, I would like to give certain set of values. Certain set of values. I'm going to delete all this one. See this, I'm going to delete this one. This formulas I will delete. Now I'm going to create my new parameters, same thing. And I'm going to add multiple values. See this, multiple values. And I'm going to make this one as new values. See this, new parameters. You can just select this one, any number of values, right? Just delete this one, cancel it. So this, go formula, and I can make length with multiple values. I'm going to create, the moment you create a new parameter, you can keep on appearing this one. So I'll be covering later stage. That means in advanced course, I'll be covering how to create multiple values, so that the moment you create these values, you can add only certain values, which is part of your advanced course. Okay. So in this case, what we did, we just created a parameter. I'll just repeat once again, go f of x and create a parameter of type length and create it new. And I'm going to name this one as shank underscore n. So that I'm going to give this one 15. Apply it, just give it OK. Now go for f of x. You will have renamed parameters. See this, all renamed parameters will be there. This shank radius, no, this one, add formula is equivalent to this 15 mm. Just give it. Now apply it, you get this one. So you can keep changing your features. So this is the most important thing. So what we learned, we have a mix of parameters and relationship, right? We have a mix. Even the formula which we gave last had been accommodated in the formulas. So to wind up the session, just to brief you out, in formulas and relationship, the number one point you should always keep it is that you need to use your parameters, which is a part of your design, a part of your feature. That means intrinsic parameter and extrinsic parameter. Number one. Then you have formulas and relationship. where you can able to use these formulas and relationship anywhere. That means you can use these formulas and relationship. You can rename the parameters. Very important valid point. When it is in diameter, you cannot rename it. When it is in diameter, you can't rename it. When it is in diameter, if you can't rename it, you will have a challenge. So that's a challenge. So you should not forget that part. 10. Whenever you design it, this formulas, yes, you can give it, but I need to have some other parameters within the specification tree which can control my design. That means this is my parameter which is controlling. Right? See this. I'm not going and disturbing any shaft or geometrical set. I'm not knowing that. So I know as a third person when it comes, this is the factor which is controlling it. See, 18, something like this. Perfect. This is one point. And number 2, very important point, tools and tips. This is very much important. What is the tools and tips? In tools and tips, your part infrastructure. First, you want to make your specification tree visible on your parameters and relationship to be visible. The first thing is your parameters and relationship be visible. So go to the second tab in infrastructure. Click on my display. If this parameter is off and this relationship is off, you can't see any of the field. It doesn't mean that the parameter is taken. So what you'll do, you just go to the sketch and you get tasked off. You don't know, right, where to change. Everything is controlled. You will have a confusion. So the first step is this. Always ensure when there is a formulas and relationship, tools and options, and ensure that these two values are visible. This is the statement. Then one more tools and tips what we discussed. Go to this tools. If this value is not visible, tools and options, right? The parameters, right? General. In general, you have something called parameters. And in parameters with value, if it is off, you can't see this value. So this is also very important. So to make it sure, tools, option, and ensure that this value is with value is visible. So that's a point which you need to understand. So these are the very, very fundamental approach for the design, where you can create only one bolt. Like this, I can create 1000 varieties of bolt with the different dimensions and configurations. That means I can have a bolt of 18 mm diameter. I can have a diameter of 20 mm, 25 mm, 26 mm, whatever the dimension. With a different material property, and so that you can configure that and store it as it is in the production process. Inventory. You go to inventory and ask, I need a bolt of 10 mm. They give you a 10 mm bolt. Similarly, your design also has to be done, and each and every time you can't design, right, n number of bolts of different and very fatigue job. You create only one, and using that one, you start creating the feature. That's objective of this design. So this is very important thing. What you learned is just one level of inputs. The same thing you're going to learn in how to put those bolts in a catalog and start using is so important for your design. Right? So with this, I will end for the day. I respect your time, so you should respect my time. Thank you very much for the day. Any doubts, please, you can ask me.